Okay, in this video we're going to take a look at some special angles. And the first ones we're going to look at are what happens on the axes, like 0 degrees, 90 degrees, 180 degrees, 270 degrees, etc. So for 0 degrees we have a picture that looks like this. And for 0 degrees we're talking about a terminal arm that sits right along the positive x-axis. So we haven't moved up and down at all. And you can think about it going through a point maybe 1 unit along. So it goes through the point 1 unit to the right, so 1 unit on the x, and none up. And so that tells you that x is equal to 1, it tells you that y is equal to 0, and the radius is the distance from the middle to that point, and in this case that radius would also be equal to 1. You can check that with Pythagoras. Do x squared plus y squared, you would get 1. Take the square root, you would still get 1. So we've got some definitions for these numbers, and now I can start to calculate, well, what is sine of 0 degrees and cosine of 0 degrees and tangent of 0 degrees, and we can use the definitions. So sine is y over r, and that's 0 over 1, so this is equal to 0. Cosine is x over r, so that's 1 over 1, which is 1. And tangent is the slope, which is y over x. You can see the slope of this is going to be 0, so y over x better be 0. Let's do this again for 90 degrees. So 90 degrees means our arm looks like this, and now we go through the point 0, 1, and the only changes is that x is now 0 and y is now 1. Our radius is still 1, and let's take a look at what 90 degrees for each of these is worth. We'll again put down the definitions. Our substitutions are now 1 over 1, 0 over 1, and this one becomes a little bit more complicated. It's now 1 over 0. So we get 1 and we get 0, and the slope of this line that's straight up and down, that's vertical, is undefined. If we continue to do this, and now we go into the other direction and we pick a point like -1, 0, we can fairly quickly see what the solutions to this will be. And so this is for 180 degrees. By the definitions, we get 0, -1, and 0 again. And finally, we can do all of these at 270 degrees. So we'll pick the point 0, -1. And we get -1 for sine 270, 0 for cos 270, and undefined for tangent 270. So tangent is undefined if the line goes straight up and down, and tangent is 0 if the line goes across the positive x-axis, which makes sense when we relate it to slope. And you'll notice that sine and cosine become 0s, 1s, and -1s depending on the relationship between x, y, and r. There are some other angles that are also fairly easy to find, but we need, like we did with these ones, and thinking about a certain picture and certain definition, we need to commit some other pictures and some other definitions to memory, to understanding them and how they work. So let's take a look at 45-degree angles. 45-degree angles are found in a special little triangle with a right angle in it and two angles of 45, making these two the same. This is called an isosceles triangle. So if this is 1 unit, this is also 1 unit, and by Pythagoras, 1 squared plus 1 squared is 2, and this side here will be the square root of 2. So this is a special triangle called a 45-45-90 triangle to some mathematicians. And we can use this to think about, if we had this as our theta, what are sine of 45, cosine of 45, and tangent of 45 degrees worth? And because we know some of the ratios on this triangle, we can answer that. So sine would be 1, it would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. And you can simplify these things by multiplying by the conjugates. or you can leave them as 1 over root 2, and tangent of 45 degrees is 1. That's a nice slope of 1. Rise 1, run 1, rise 1, run 1. So there's a 45-degree triangle. There's also another special triangle which will deal with angles of 30 and 60 degrees. It's called the 30, 60, 90 triangle, and it looks like this. We've got an angle of 30 degrees, we've got a 90 and a 60 degrees. Across from 30 you'll get the smallest side, which is 1. And across from 60 you'll get the next biggest side, which we call root 3. 1 squared is 1, the square root of 3 squared is 3, and 3 plus 1 would be 4, and the square root of 4 would leave this side as 2. So there is the 30, 60, 90 triangle, and now we can come up with what is sine of 30 degrees. And we can say, well, it's opposite over hypotenuse. What is cosine? It's adjacent over hypotenuse. And what's tangent? It's opposite over adjacent, which could become root 3 over 3. But we can also do the 60 degrees as our theta. And so if this is our angle, theta, on the top here, this is where we're looking from, the opposite to 60 degrees is root 3, and the hypotenuse is 2. The adjacent to the 60 degrees is 1, with a hypotenuse of 2, and now the opposite is root 3 with an adjacent of 1, which is just root 3. So it's important that you understand how we get these 45, 30, and 60 degree ratios for sine, cosine, and tangent, which really means memorizing these two triangles, the 45, 45, 90, and the 30, 60, 90 triangle. Let's put this all together with the ASTC rule that we did in a previous video. We can start solving some questions. So here's an example. Find all the angles where cosine theta is equal to root 3 over 2 on the interval from 0 to 360 degrees. So basically this just means on this interval. I know that this is a positive number, so I can look to see where my solutions will be taking place. So I know that I have solutions because cosine is positive in quadrant 1 and quadrant 4. There's my solutions. And I know that cosine theta equals root 3 over 2 is going to require me to use the triangle that's got a root 3 and a 2. And now I need to remember which angle gives me root 3 and 2 as adjacent and hypotenuse, and which one gives me the 1 over here, and that's of course 30 degrees. Across from the smallest angle is the smallest angle. This would be 60 up here. So I need to think about the orientation. This theta is equal to 30 degrees, and really that's my reference theta, my reference angle. And so combining these things together, I've got my ASTC says I've got an angle here of 30 degrees, and I have another solution here with a reference angle of 30 degrees. And so my solutions, my overall solutions are 30 degrees and however far this is, which is 360, go back 30, or 330 degrees. Let's try one more of these. So I want to know all the angles where sine theta is equal to negative 0.348. Now negative 0.348 is not one of the things that we've covered today of 0, 90, 180, 270, or 30, 60, 90, or 45, 45, 90. This is just some kind of random ratio that we have, but I can still go through the same steps. So my first step was to determine how many solutions and in which quadrants we are using ASTC. So I like to draw a picture, and ASTC, and sine is negative, tells me that I'm in these two quadrants for my solutions. So now I need to go, for step 2 is to go and find my reference angle. And the reference angles are going to be the same here and here. And the way that I find the reference angle is, first of all, I take my little ratio, sine theta is equal to negative 0.348. If this was 0, 1, negative 1, undefined, any of the ones that we would use the special triangles for, so 1 over 2, root 3 over 2, all those sorts of things. If it's any of those, then I would go and use special triangles, and 30, 60, 90, 45, 45, 90, like I did in the last question. If it's not, then I need to use my calculator. And to find the reference angle on the calculator, what you are doing to get this reference angle is you need to type in inverse sine. So to get rid of sine on this side, I do inverse sine, and to get rid of whatever I do on one side of an equation, I do on the other side. But I have to take this ratio here and make it positive. So you notice it was negative 0.348. I have to make it positive. At this point, you are reliant on the calculator. So you actually have to have a calculator and type in inverse sine 0.348. And you should get about 20.4 on your screen. If you're getting 0.355 on your screen, then you're in the wrong mode. And a button near the top of your calculator says mode. If you press that, go down 2 spots, you'll see where it says radian and degree. Just switch over to degree mode on your calculator. We need to make sure that we're calculating things in degrees. Next year, if you take Math 12, then we start to calculate things in other angle measures, including radians. So, but this year we're going to do everything in degrees. So here's your reference angle. So now that you know it, you know that this is 20.4 and this is 20.4 degrees. And so now you can go to your last step, which is to state your solutions. There are 2 of them. One of them is 180 plus another 20.4, which is 200.4 degrees. And the other one is 360 degrees and go back 20 degrees, which gives you 339.6 degrees. Okay, we'll see you in class to get some more practice with this.